The 16-pin variable speed motor is very similar between our air handler and furnaces. And in fact, you're going to find that this motor will be very similar between all manufacturers that it is applied to. The specifics for us will be the programming within the module. So the module must be programmed for the exact model number unit it is being applied to. The first step in troubleshooting any variable speed motor is to ensure we have high voltage feeding the motor. So when I look at the schematic for this furnace, we can see this motor is tied into my circulate hot and my circulate neutral wires. So the first step, looking at the back of that connector to ensure I have 115 volts if it's a furnace, or if it's an air handler on those same two connectors, I want to make sure that I have 240 volts feeding the motor. If I have voltage feeding the motor but the motor does not run, my focus will then be on the 16-pin connector feeding the motor. Most of the individual pins of that 16-pin connector are inputs into the motor telling the motor what capacity it needs to run at. The only pin that is a feedback is pin number 16. And that is going to be a DC pulse back to my board that controls my fan CFM LED. So when the motor is running, every time that fan CFM pulses, each pulse is a request for 100 CFM. Now that is not actual airflow, that is requested airflow, but it also provides me information that my motor is communicating back to the board and my motor does have a request to move airflow. If my motor does not run, I'm going to use that 16-pin wiring harness to test the motor and see if it runs with a G-call. Now as I look at that 16-pin connector, I can see that one of my wires is going to be blue. And that blue wire is going to be common, and that's going to be pin number 1. So it's going to be a good reference point on where all my pins are going to be. Now if I can apply common to pins 1 and 3, and apply 24 volts to pins 12 and 15, that will simulate a G-call and my fan should start up and run at 50% airflow. Now trying to make all these jumper wires happen can be challenging. So we do make a wire harness kit, and that kit number is 34-3403-HS. And that's just a simple wiring harness that has 4 wires into that Molex connector. Common will be on 1 and 3. The red wire will be on 12 and 15. So if I apply 24 volts to the red wire and common goes to common, that is going to simulate a G-call for my motor and I should run at 50%. Now one thing I recommend is we start doing retrofits in the field and we start pulling out units regardless of what manufacturer it is, and if it has a 16-pin variable speed blower motor, I would recommend removing the harness, cutting off the unused wires, and you can build your own harness in the field without having to purchase one. So whether you want to purchase or whether you want to build your own is up to you, but having a quick start guide can make life easier for you when troubleshooting these motors. We also make a publication that has a much deeper dive onto these motors, as well as constant torque and outdoor variable speed fan motors, and that publication is 34-3402-04. This publication can be found on our e-learning course for variable speed motors. So when you visit our learning management system and you sign up for the variable speed motor course, in the top right of that course will be a tab called Resources. Click on the resource link and you can download the publication. One item in the publication that talks about what each one of those pin connectors are. So as we noticed, 1 and 3 for common and 12 and 15 for hot is a G-call. But if I add pin 6, I get a Y1. If I add pin 14, I get a Y-call. So I can now simulate varying calls for capacity and see how my motor is ramping up and down. But generally speaking, the motor will either work or not work, and the simple test of applying a G-call to the harness will let you know if the motor is functional or not.